association rule mining. Okay, so it is like any recommendation which will be done based upon the association rule mining, which is a key part. So what we are going to deal is, it is purely for retail stores. It is purely for retail stores. So where what happens when you buy a product like shampoo. So you buy air conditioner, plus soap. So when you buy a beer, you buy chips or peanuts together. When you buy a milk, you buy biscuits plus breads. So likewise, each and every consumer will have a pattern of buying it. Okay, buying together. Now, I want to understand what are the products are in a basket, which means when a person goes to the shop, supermarket, so he goes, or hypermarket, okay, he goes with a basket and fills into the basket and comes to the counter and he bills. So once he bills, the bill is generated with the transaction ID and the customer ID if required, and then the products what all present. So within the transaction ID 11111, same transaction, same customer, one. So same transaction ID, products. So same first transaction, and same customer say 100, customer ID is 100, same customers buying different products. So beer, chips. Take the second transaction, second customer is buying likewise he buys collectively. So after this transaction is done, he's going to have in a basket and then is going to take to his home. Okay, so that's how the transaction is done in the retail shops, retail stores. Okay, so now what I want to understand, what are the products which is collectively and frequently purchased together by customers, more customers. So if more customers are buying a product, okay, together of a same product, where what I do is like I understand and find out what is the maximum percentage of level this product are purchased together. So I have a shop entrance and I have a soap here and I have a shampoo here. Okay, so whenever person wants to come and buy soap, he will buy and he will go out of the store. Okay, so now with my analysis what I do is like around 70% of our customers who buy soap and shampoo together. So what I do is like I go and place the shampoo over here. So what happens? My intention is to buy soap, but by seeing this, yes, this is also my need. I need to buy it. I pick up two things and then I come to the counter. So what it means is like collectively placing a products which is of similar needs and as well as the customer likings together, so that one product I will promote, which in turn sell two products. The cost for my marketing is one product, but the selling is of two products. Okay, so this is called association tool mining, which is also called market basket analysis. So this will lead into the recommendation of a product. So yesterday, I think Asha asked Target with this recommendation engine, right? Okay. So now what happens? So collectively, I purchased together. Okay. Sorry, I know. It's enough. Okay. So collectively, products are together. So with this, I know the customer ID, what all frequently buyed, and I profile them. So what is the key part of this? What is the key part of this? Which data is the key? Which part of a data is a key for the, okay, products and its frequency? Okay, great. So the key is going to be customer ID. Okay, when you have the customer ID and the profile, and you can profile. So if you go to the supermarket or hypermarket, sir, can you give your mobile number, please? And they ask, while you are standing in the queue for billing, they ask you to fill a form. So its main purpose is to profile them. Once they profiled them, they can know what Krishna is buying, what Krishna needs are, what he did for last 6 months, when he came to the shop, when he not came to the shop, why he not came to the shop. All the kinds of profiling once he does, that is the biggest asset for retail stores. So based on the need of the customer and based on his purchase behavior, the products will be recommended, offers will be coming, all those things will be in line with the profile. You agree? So based on this only, the Target example, Target did the promotions and offers to that particular woman. Is it clear, Anup? Okay. So in line with the customer ID, everything is there. Now in India, the retail stores are biggest in demand, and as well as the data science for retail stores are highly paid. Why? Because of the upcomings of online stores. So now you can buy the groceries in online. Everything you can buy in online. Okay, a lot of people buys in online. The retail stores are just, they have less kind of profits and less customers, and they want to market it more with a lot of offers so that they can compete with the online and as well as they can sustain the market. So that's the reason a lot of MBA guys and as well as in combination with the data science guys, what type of change you can bring to the retail store so that attract my customers to come to the store, visit and purchase the things. Okay, and purchase the things. So all this is a good kind of a sign where you can bring some new kind of a dimensions to the retail stores of promotions, recommendations, offers to make the customers to come into the stores and buy. While buying, the biggest asset is going to be the customer profile. Once you profile them, you build anything to that, you can easily market to them and make them to come into the stores. Then whether they purchase or not is a different game. Got it? So that is called association rule mining, which we are going to see how what are the products which is frequently buy together, which helps to promote one product and try to market by keeping all the products together which are relevant, which makes the customer to buy the similar products. Got it? Is it clear what we're trying to do here? Any queries on this? Okay, good. Fine. So it is the one of the very popular method. Okay, identifying a strong rule discovered and between the products and between the different baskets. When I say different baskets, is equal to different transactions. Okay, and so this is some of the examples when a customer buys onion, buys potatoes together. So all those is examples of what we have seen. And with this, we can make a kind of a set of rules, which all the products to be combined together while placing in the stores. Okay. If you look at the bill counter, right? When you stand for the bill, so especially in Total, Big Bazaar, okay, where the chocolates and the batteries, razors, all are kept near the billing counter. Okay, is there any specific reasons? Essentials and attract children's shelf space. Okay. Okay, good. So it's more of essentials and attract children's. While you are standing in the queue, the children's will ask for chocolates, and it is in another kind of a sales. Okay. So that is the reason. And while you're standing, you might forget to buy the small things. While you're standing, you'll think and see all those things which you feel is required. It's my essential needs. So that's the reason it's placed near the billing counter. Yes, Besar, good. Good, Anup and Besar. Okay. And good, Satyam. And in hypermarket, if you go, there is shelf will be there. Ground shelf, that is a racks, and above racks are present. And the vendors to place the product in the first rack is costly than the vendors to place in the bottom rack. Any reason? In hypermarkets, for a vendors to place the product, the first rack is costly than the bottom rack. Okay, excellent. Catches customer attention. Standing will have a better look at first rack. The chances for the last one is little. Proximity at the level of 5, easy access, excellent. Okay. So why? Because the point of sale for the product which is present on the first rack is higher than the point of sale for the products which is present in the bottom rack. So that's the reason it is costly. Okay, good. So all this also is a point of kind of a data science where which of the products can be placed at the top and which of the products can be placed at the bottom, at the middle. So which promotions you can make to make a better sale in the retail stores. So those are all the key things. So now we'll get into this association rule mining. Okay. So this is the sample input data. Okay, I have a different sample with a small set of data. So but the concepts are everything is same. Okay, whatever you apply to a large volume of data and small volume of data, it's going to be same. And I had a question from Ashir. What are the different projects or example where we can use association rule mining? Okay, good. So association rule mining is a better fit where all you have a transaction and where all you have a kind of a purchase or a consumers, you can apply the association rule mining. So the majority of use cases, this has been applied in the retail industry, that too with a specific to stores. Fine, Asya. So if any questions is missed, really sorry. If you don't mind, can you please repaste it? Okay. So if you look at there's a transaction ID and the items purchased together. So the basket model comes from the transaction. So in a single transaction, what are the products purchased together? So in a single transaction, what are the products purchased together? If you look at here, citrus fruit, semi-furnished bread, margarine, ready soup are purchased together. And similarly for transaction 2, this was the product purchased together. So I have many transactions and each transaction is going to be equivalent to a one basket. So that's the meaning of it. Transaction is equal to basket. In a basket, what all the product purchased together? Hi, Madhu. Okay. So now we'll go and start working on the practicals. Join detail lead. Okay. So it is better to make a kind of a documents because when you start working in data science, right, it is not the only technology of R you will be working. You will be working in many things, and it will be difficult for you to. Okay, it will be difficult for you to remember all the kind of commands because once you start working on a single technology for years, then only you know in and out of the commands. Okay, so when you start working with the data science, you'll be working in multiple technologies. Sometimes you'll be working with Excels, pure Excels also. There is you will be working. Okay, a lot of calculations also you will do in Excels for quick turnaround times, and as well as you will be working with the Java, sometimes with Python as well. Okay, and sometimes with R. It's better to make a kind of a document which has the frequent use of comments and as well a kind of a easy access for different models. What are the packages you want to use it? So that will help you a lot. Okay. Fine, Mother. So just we are starting with the practical. Just follow on from here. Okay. So as usual, we have the list of codes for R, and here we are going to use a different types of a package which is called A rules. Okay, which is called A rules. Okay, and under that A rules we have functions which is called APORI. Okay, where in previous thing we have seen the TF-IDF function and K-means functions. Here we are going to see the different functions which is called APORI. Okay, so we can install the package if the package is not present in your R, and as usual we can set the working directory to read the data from that particular location and to write the data to particular locations. Okay. So now, previously we have seen read.csv, read.table to read a CSV file or a different separated, comma separated file or different delimited files. Now we have a mechanism is called a transaction, and the file should be in this format only. Okay. Transaction ID are the products. So first column should be a transaction ID and second column to be a products. So this it should be. Okay. So now, so I'm going to read the transaction. Remove duplicates is equal to false. If any duplicates is there, don't remove it. And format is equal to single and separated by comma, and columns is equal to first and second column. The format is equal to single. Okay. What it means is like it's a single basket. It's a single basket where you have all the transaction which is present in transaction ID and the kind of products in the file. So that's the meaning of it. It is single. Okay. So where each line will have the transaction ID and the product name. That is called single. Here we are not require customer ID. We are not going to profile them and not going to analyze based on the customer ID. It's only a market basket analysis. It's not based on customer. Fine, Sundar? Okay. So now this reader transaction will read the data set in the form of a transactions. Because Apori understands only transaction data, it does not understand the CSV file. Normal data frame it does not understand. It will be in the form of a transactions. So when you read this data set, okay, we have 7 transactions. Previously it used to get the 7 rows, number of rows, number of columns. If you look at the transaction, 7 transaction has been done and 6 items purchased. 7 transaction, if you take a uniqueness of this, it will be a 6 products purchased. So now I'm going to apply to the Apori model. The input is going to be the transaction, and I'm going to have a parameter called support confidence, and target is going to be the rules. So what is the support and confidence? Okay. The support and confidence. So if you look at this, proportion of transaction in dataset which contain the interest, which means to what portion of a data the product should be present in the transaction. For example, today I made 100 transaction. In that, only one time one product is coming. So that product I cannot use for my analysis. At least minimum what level of percentage a product should be present in all the transaction, that product only will be considered for the association rule mining. That is called support. And confidence, okay, number of transactions divided by, that is to what level of total number of transactions. For example, a product is coming 10 times, but the total transaction which is happened on that day is 1000. So which is 10 by 1000. Okay. So if you look at 10 by, so only 0.01 percentage, only 0.10 percentage of a product is present in total of transactions when compared with the another product. So to what level of confidence for a product to be present, which I have to take into account for my analysis. So if you look at the examples, so take an examples, 2 examples. So Jack the Ripper and Strawberry. So which means whenever the Jack the Ripper is bite, Strawberry blonde is also bite together. Take Jack Ripper as X and Strawberry as Y. Number of transactions involving both Jack and the Jack Ripper and Strawberry divided by total number of transactions will be the support. Okay. So what level of percentage it should be present so that this product are purchased together, and we have a minimal number of transactions which I take into account for my analysis. So once again I am explaining number of transactions involving both the products purchased together. So what are the transactions? Number of transactions, a purchase of both shampoo and air conditioner together divided by total number of transactions. So that should be minimum of 50% for me to consider that basket, else I will not consider that basket. So what extent I should be considering is what called support. And confidence, number of transactions where Strawberry blonde was bought when the Jack was bought divided by number of transactions where Jack the Ripper was bought. So this is to what extent of a relationship between the two products divided by the number of transactions of the primary product. So when I say primary product, whenever for any product you will have a primary. Based on that primary only you will add the child products to that. So when you will not buy a peanuts because of peanuts you buy a beer. No. You buy a beer because of that only you buy a peanuts. So to what extent of weightage the primary product is got. So that is called confidence. So when beer is buy, I am very confident that peanuts will be buy together. So that level of percentage is called the confidence. Is it clear? Ashish, is clear? Between support and confidence only the denominator is different. Yes. No, it is reverse. Here it's reverse. Okay. Here Jack the Ripper and Strawberry are becoming like a supervised learning. It's not a supervised learning. Okay, it's finding out between the two variables. No, we will not give the two variables. Automatically the system takes. Okay. And fine, Basad. Acceptable confidence level is 50%. So it's as we decide based upon the number of data. So data science, there is no fixed rules as such. So the minimum what we can have is a 50%. Okay. And to get a better accuracy and to promotions to be fine, people can have 80% as well. Okay. Fine, Anup and Sundar. How to differentiate numerator in support and confidence? Okay, I'll give that. Okay. So we'll see that. So why isn't XU? It should be X intersection. Okay. So it's union of part. It's not an intersection. Okay. So why is this? Because when a Jack was bought, was also bought the Strawberry. So that's the meaning of it. So there comes the union. So this is the formula for confidence. Okay. So now, if you look at the APORI, the parameter is going to be support I am making as 50 and confidence also 50%. 0.5 is equal to 50%. And target is equal to rules, which will give me a set of rules on what basis a product X is buyed with Y. So that's the kind of a rules I will be getting out. So if you run this, so now I will be getting a certain association rules between each and every products. Okay. So if I inspect the rules, it says it's called left hand side and right hand side. Whenever a chocolate is bite, the pencil also bite together with a 57% of confidence. 57% of support and 100% it is confidence where chocolate and pencil are bite together. Whenever a pencil is bite, that is a primary product, and a chocolate is bite, it's 57% confidence, and 0.6, that is a 66% of confidence and 57% of support. Got it? And a lift of 1.16%, that is a increase between this and this. So which is an observed and expected can rise to 1.16. So the lift is only a kind of information which is not used for any analysis. The main purpose is support and confidence only. Okay, so that's how you determine what level of product and which are the products is purchased together, while and then what are the products can be put together for promotions. So one product you will promote, which in turn results into a sale of multiple products. That's the main objective of this market basket analysis. Okay. How does the retransaction function understand first column transaction ID, or is the transaction always, yes, transaction ID to be always first column. Okay. So that's the reason we are saying it's a single. So which means the data set should be in this form of transaction ID, comma the products. So we say 1, 2. Fine, Basar. What did you mean when you put 0.5 support and confidence? It's a natural language. Okay, it's 50%. Fine, Anup. At least 50% of a product should be always buy together, and confidence also should have 50%. Okay, so it's our mechanism, it's not fixed. So based on analysis, you can also increase to 80% or 90%. How will you have to determine which are the majority of a products to be purchased or put together? So that's the main objective of this. It's as decided based upon seeing the data and how well you want the accuracy. Fine. So if it says 100 products you have to put together, I cannot re-alter my retail stores. Okay. So majority of things, 90% I can believe this product will be purchased. Then only those products bring to my attentions. So then you can change it to 0.9. Got it? It is varies, it's not fixed. By trial and error method we'll be changing it. Yes, the algorithm will give only the products which falls under this category, under this range of confidence and support. Okay. Other products it will not show. Okay. So if you look at the inspect will give you the rules. So now I am a kind of a store manager. I want to know where I will place my products. So I will place chocolate and pencils together, and I will promote only chocolate. So in this case 100% I am confident that whenever you purchase a chocolate you will buy a pencil together. So in this case I am 66% only confident that when you buy a pencil the buying of chocolate is less. But you can see that 57% of customers is buying pencil and chocolate together. Left hand side is going to be the primary product, right hand side is going to be the sub products. The right hand side, the primary product makes a tense or intends to buy the secondary products. So that's the meaning of it. So I will promote only chocolate. In turn it sells pencil. Correct, Sundar? Is it clear? Yeah, can we get the support and confidence for all the products? Yes, you make 1 or point and at least 1% of transaction. Do you see that? Coke and eraser buy together, it is 14%. Okay. And eraser and Coke purchase, it is only 14% of support. Coke pencil, pencil Coke, eraser pencil, Fine, Arun. So the empty is, it is not able to calculate. Okay. So those data are primary product is not determined, because if you look at the confidence is very less. Do you see that 0.14 is a confidence? Okay. Fine, Arun and Anup. 0.14. Do you see that? Okay, it's 0.14. Support is the first attribute we have to look. When the support is there only, you can go for confidence. If the support is not there, it is no point in going for confidence. Okay, only 14% of transaction which is having the combination of products purchased together. Okay, the primary weightage will be given to the support. Only more than the support, so 28% only pencil and marker is buy together. So I don't want to concentrate on the 28% of customers. I want to concentrate on 57% of customers what is buying. That only I will concentrate. Then only I will look for what level of confidence this will be buy together. Got it? Fine, Arun. So that means there are more transactions for pencil than chocolates. Transactions are more. Okay. And in line with the transaction, what is the combination of products buy together also, it matters. Got it? Okay. So this is the plot. So this for checking only first product. This for checking in a plot. You can check in a graph visually, that's all. So this is to inspect the transactions. So we have read the transaction, right? This is how the transaction will be converted. For item 1, transaction 1, it converts into an array of, that is the vectors of the products purchased. Fine bin. So this is how it converts. You see the transaction items. So the first column should be always a transaction, second column to be a list of products. Then it converts into a list of vectors for each product. What is the each transaction ID? What are the list of products which is purchased together? So that's the meaning of it. Okay. So this is the graph is item frequency plot transactions. That is chocolate, what is the count? Okay. And Coke, pencil, marker, what is the count in the transaction? So in the transaction, just if you go here, so count of this 1, 2, 3, 4, right? So out of all this transaction, what is the frequency of this transaction? Got it? It is 4 times. When you add everything, the number of frequency plot. Okay. So around 60 percentage. Around Coke occupies the data of 20 percentage. Around cookies 20, this 20. But pencil has a frequency of product which is higher when compared to any other product. So that's the meaning of it. Fine, Sundar? So total number of products. So it is the number of products divided by total number of transactions. Okay. No, not a combination. Can we say 20% is a combination of chocolate and Coke? No. It is only each product, how many times is present in the transaction. That's all. It is not a combination. It is only a frequency plot for transaction data, not for the basket rules. Okay. So only a frequency plot. So number of transactions divided by the total number of transactions. No problem, Anup. Ask many questions you raise. I welcome that. Okay. So I want it to be clear. Okay. Yes, that's for each item. Fine, Anup. Any other questions? If I missed any question, can you retest it, please? Okay. Any other questions? So is there a way to visually plot basket rules? Okay. So visually plot, right? What we can do is like we can export the data set, okay, from the output what we got, that is a summary output. Then we can plot between the confidence, support, and the products. So the main thing is like the primary product and the support and confidence in the secondary product. So we have to export that to Excel, and then we have to look in the graphical format. So mainly this is a rule, okay, and this is not a data frame. So once you get the result set in a data frame, then we can export and look for the visual representation. Since it's a rule, it's only for an indication. So what level of actions I have to take? So you will be getting a result set of this form. Can you choose a set of products? So while you are filtering, while you are giving the transaction, right, before you give the data to the transaction, you can filter the products as well. Fine. So before you input the data to the transaction system, you can feed it. Okay.